Okay, so for your quiz tomorrow, there's basically 5 different things you have to do, and we're going to go over each one of those right now. If you can do these, you're going to be fine tomorrow. Practice quiz 7.5 to 7.6, we need to graph each function and state its domain and range. Now, I've written down the rules here for your translations. Okay, remember that when we add on the inside, we're shifting to the left. When you're subtracting on the inside, you shift to the right. Add on the outside shifts up, subtract on the outside, you shift down. So you're going to need to remember those. Now, when I say shift, we like to shift the anchor point and then just kind of remember a pattern of where to put the other points, okay? And so we're adding 1 on the inside, so the anchor point, which would typically start at 0, 0, would shift left 1 unit. And then because of the -2 on the outside there, we would then shift down 2 units, okay? And that's where we put our anchor point. Now this is a square root function, so you have to remember for square root, you're then going to go right 1, up 1, put another point. Then again, from your anchor point, go right 4, up 2. And then you draw your function. Now for domain and range, what you need to remember is what I call vanilla square root domain and range. And so let me make this part right here just a little bit smaller so I have some room to work with. Put that right over here. So if we were just going to look at vanilla square root, and by vanilla square root, what I'm talking about is just y equals the square root of x. You need to know that its domain is x greater than or equal to 0. The range is y greater than or equal to 0. Okay? And then when you add and subtract, you shift the domain and range. So because domain is the one that deals with left to right, okay, and we shifted left 1 unit, this domain then also gets shifted left 1 unit, and 1 unit to the left of 0 is going to be x greater than or equal to -1, okay? 1 unit to the left of 0. For the range, we shifted down 2 units, so this also gets shifted down 2 units. And so for the range, we're going to say y is greater than or equal to -2, okay? Because again, 2 units below 0 is -2. Now, same deal for the cubed root, okay? We are shifting the anchor point to the right 4 units from the origin. So 1, 2, 3, 4. There it is right there. But then there's a different sign pattern, okay? For the cubed root function, you're going to go to the right 1, up 1. That's the same. But then you're also going to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 2. And then you go in reverse. Left 1, down 1. And then left 8, 2, 3, 4, 5, 6, 7, 8, down 2. And so then you want to draw your smooth curve, or as smooth as you can make it. I didn't really hit that point, but it's supposed to go through that point right there. And then here as well, okay, draw your curve. Now the nice thing about the cube root function is that the domain and the range never change. Okay, the domain is always all real numbers. No matter what I add or subtract on the inside, the domain is all real numbers. And the same with the range. Okay? No matter what I add or subtract, your range is all real numbers. There we go. All right, so moving on. Describe how to attain the graph of g from the graph of f. Well, here's g of x. I see it's the square root of x plus 2. Here's f of x. It's just the regular old square root of x. So notice what's different is we're adding 2 here. It's on the inside. So g of x is the graph of f of x and because it's add 2 on the inside, it's shifted left 2 units. Now down here we have negative the cube root of x minus 3 plus 5, and f of x is just regular old vanilla cube root. Now there's 3 things going on right now. I see a negative on the outside, a minus 3 on the inside, and a plus 5 on the outside. So g of x is the graph of f of x, but because of the minus right here, okay, it's reflected vertically it's shifted to the right 3 units. And then it's shifted up 5 units. And that's that. Okay, so answer each of the following questions. You'll need a calculator to do this on your quiz tomorrow, but I have one that you can look at today. The approximate time, t in seconds, that it takes an object to fall a distance d in feet, t is equal to 0.85 times the square root of d over 16. Now Sammy is parachuting and falls 169 feet, and that's going to be important. Before she opens her parachute, how long does it take Sammy to fall this distance? Now, we need to plug this into a variable here. Okay, you're plugging it into one variable, you're figuring out what the other is. So you have to ask yourself, is 169 feet a time or is it a distance? Clearly that's a distance, so we're going to plug that into d. So t then is equal to 0.85 times the square root of 169 divided by 16. And in your calculator, that's exactly what you're going to type in. 0.85 times the square root of 169 divided by 16. So we hit enter, and it gives us a number there. Now it says, how long does it take Sammy to fall this distance? And so this is in the units that it tells you time is, that's in seconds. So it's 2.7625, 2.7625. And again, time is in seconds, so this is in seconds. Now, a car traveling on Interstate 270 was involved in an accident. To approximate the speed of the car at the time of the accident, the police used this function. S is the square root of 35 times 0.5 and then times d, where S is the speed in miles per hour and d is the length of the skid mark in feet. That's important to remember. Speed, S, is in miles per hour, and d is the length of the skid mark in feet. Now the driver said he was traveling at 40 miles per hour. Automatically I see that miles per hour. Oh, speed was in miles per hour. So I'm going to be taking this 40 and I know I'm going to be plugging it into S. All right, it says what should be the length of the skid mark, and your answer should be correct at 3 decimal places. Okay, so we'll say 40, because I plugged that into S, is the square root of 35 times 0.5 times d. Now to figure out who d is, what I'm going to do is I'm going to square both sides. So from there I have 40 squared, and when I square the square root, those cancel, we'll get 35 times 0.5 times d. So then I'm going to divide by 35 times 0.5 on both sides. And that'll figure out who d is right there. So we have 40 squared. I want to know who that is first. Whoops, not the inverse of 40, but square root, or the square of 40. That's 1600. Then I divide by 35 times 0.5. And you'll notice that I put my answer, or my denominator rather, in parentheses there. And so we're getting 91.42857. It said round to 3 places after the decimal point. So this is what I want to round. Do I round up or down? I look to the number before. Since that's 5 or greater, I'm going to round this number up. So my answer will be 91.429. 91.429. And then, hey, what is distance in? I need some units right there. It's in feet. And now we get to the meat of the quiz here, solving each equation and checking for an extraneous solution. Now these two are fractions. If for some reason you can't see the fraction bar, I don't know why that is. Okay, we have 2x to the 3/2 power is equal to 16. So the first thing I'm going to do is I'm going to divide each side by 2. So we're going to get x raised to the 3/2 power equals 8. And again, what I did there was I divided by 2. Divide by 2. I'm not going to be able to write my steps out each time, Now what I'll do is I'll raise each side to the reciprocal power. I'm going to do that in a different color here. I'm just going to get my red color. And I'm going to go like this. Raise, raise. Now it was 3/2, so I now want to go 2/3. And this, I want to go 2/3. And so x, we know, this is now gone, equals 8 to the 2/3 power, which is, and I'll go to my calculator here, 8 caret parentheses 2 divided by 3, close the parentheses, enter, x is equal to 4. Now I want to check. And so we're going to go 2 times 4 raised to the 3/2. Does that equal 16? And so I'll go and I'll type this into my calculator here. 2 times 4 raised to the 3/2. Hey, that equals 16. It's good to go. So x equals 4 is our solution. Now we have x minus 5 raised to the 5/3 minus 73 is equal to 170. So the first thing I want to do is I want to add 73 to both sides. We'll have x minus 5 raised to the 5/3 power is equal to, when I put that over here, 170 plus 73 is 243. So now what we're going to do is we're going to raise each side to the reciprocal power of 3/5. It doesn't matter that one side is brackets and one side is parentheses. This is what's important, raising each side to the 3/5 power. So this is gone. We're left with an x minus 5 is equal to, and then 243 caret 3 divided by 5. Enter. And so we're getting 27 there. So then I'll add 5 to each side. X equals 32. Now I'm going to check my answer here. I'm going to plug in my 32. So we're just going to say 32 minus 5, and it was raised to the 5/3, minus 73. Does that equal 170? Well, let's go to that calculator. 32 minus 5, we're going to raise that to the 5/3 power, and then we're going to subtract 73. And that does equal 170, so it checks out. X is equal to 32. Okay, so now we have the cube root of 4x plus 2 is minus 6 is equal to negative 10. Again, you're trying to isolate your radicals, so I want to get this all by itself first. So I need to move the minus 6. I'm going to add 6 to both sides. We're going to get the cube root of 4x plus 12, plus 2. Cube root of 4x plus 2 equals negative 4. Now what we'll do, we're going to cube both sides. And the reason I'm cubing is because this number and this number need to match. Okay? The opposite of the cube root is the cube. The inverse of the cube root is the cube. And so what's going to happen is this and this will reduce. We'll get 4x plus 2 is equal to, now I know what negative 4 to the 3rd power is in the top of my head, but if I didn't, I just go to my calculator and type that in. We're going to get negative 64. And so then I'm going to subtract 2 from each side. 4x equals negative 66. We're going to divide by 4. And we're going to get x equals negative 66 fourths, which I know both of these are divisible by 2. So if I divide that by 2 and divide that by 2, that equals negative 33 all over 2. Now I need to check my answer. And so I need to do the cube root of 4 times negative 33 over 2 plus 2, and then I need to subtract 6. Does that equal negative 10? So we do the cube root. It's option number 4 in the math menu of 4 times negative 33 divide, whoopsie, one too many 3's, divide by 2, and then we add 2, close the cube root, and subtract 6. And we are getting negative 10, and so our answer, x is equal to negative 33 over 2. So now over here we have x plus 5 is equal to the square root of 21x plus 1. So what I'd like to do is, this square root is bothering me. I need to get this x out from underneath there. So I'm going to square both sides. Now I know the right-hand side, the square root and the square, we're going to be left with the 21x plus 1. For x plus 5 squared, what we'll do is we'll do that right over here. We'll have x plus 5 times x plus 5. Remember, you're going to expand this. A lot of kids say FOIL here. X times x is x squared. X times 5 is plus 5x. 5 times x is plus 5x. And 5 times 5 is plus 25. And so we'll have x squared. That makes plus 10x. And then we have plus 25. And my pen is no longer working. Oh, there it goes. Okay, plus 25. This is a 25. There we go. All right, so now we're going to subtract 21x from both sides. 10x minus 21x is minus 11x. And then we're going to subtract 1 from both sides. And that equals 0. I need to do this because we have a quadratic equation, and when you're solving a quadratic equation, you want it to say equals 0. So now we're going to factor. Oh dear, what's going on with my pen? Here we go. And so we have an x and an x, and now I need to think of numbers that multiply to give me 24, add to give me negative 11. So I'm going to make a list over here. First of all, I know both sides must be negative because it multiplies to give me a positive. That tells me the signs are the same. Adds to give me a negative, both must be negative. Now negative 1 and negative 24 do not work. Okay, that adds up to negative 25. Negative 2 and negative 12 is no good. That does not add up to negative 11. And then we go negative 3 and negative 8. Well, there we go. Negative 3 times negative 8 is positive 24. Negative 3 plus negative 8 is negative 11. Now set both pieces equal to 0. So add 3 to both sides, x is equal to 3. Add 8 to both sides, x is equal to 8. But now we need to check. Checking, we're going to plug 3 into our original formula here. So we have 3 plus 5. Does that equal the square root of 21 times 3 plus 1? Well, 3 plus 5 is 8. Does that equal 21 times 3 is going to be 63 plus 1. 8 does equal the square root of 64. That works out. So x equals 3 is a solution. Now let's check 8. Okay, so we're going to go 8 plus 5. Does that equal the square root of 21 times 8 plus 1? Well, this here makes 8 plus 5 is 13. Does that equal? And I don't want to make any mistakes, so I'm going to come over here to my calculator and I'm going to figure out 21 times 8 plus 1. 21 times 8 plus 1, and that equals square root 169. And does the square root of 169 equal 13? It does, and so that is an answer as well. So both work out. Now, if either of these did not work out, you would just cross your answer out and you'd have only one answer. So the last one we have is the square root of 4x plus 1 equals the square root of x plus 10. Again, radical. We need to square both sides in this case. We're going to get 4x plus 1 is equal to x plus 10. And then it's just solving a linear equation. Subtract your x from both sides, you're going to get a 3x. Subtract 1 from both sides, you get 9. Divide by 3, x is equal to 3. Now let's do our check. So we have the square root of 4 times 3 plus 1. Does that equal the square root of 3 plus 10? Well, that's the square root of 12 plus 1. Does that equal the square root of 13? And yeah, the square root of 13 is the square root of 13. That checks out. X equals 3 is our answer. So the last thing you need to do is match each function to a graph. And there's going to be 4 of these. I've only done 3 here. The first thing you need to realize is that right here I have a 1/2 power. And you need to know that that is the same as the square root. Now it'd be helpful if you can identify shapes. Remember that square roots, okay, for the square root, it looks like that. The cubed root, okay, is the one that goes like this. So clearly, this is our cubed root function right here. And the only one that's going to match is letter B. So now we have a decision to make. Right here, f of x is the square root of x minus 3. And here, f of x is the square root of x and minus 3 on the outside. Then it's just remembering where you shift. Subtracting on the inside, that is a shift to the right. And so that is going to be this one here because we shifted that anchor point to the right. And then there, we're shifting down 3 units. And so this one right here is letter C. Again, there's going to be 4 of these. There's going to be 2 square roots, 2 cube roots. And you're going to have to match which one is which. Okay? All right. Now, that's it for today. If you want to see an example like one of these over here where you have an extraneous solution, go back and watch the video for the section 7.6 notes because there's one with an extraneous solution in there. Other than that, I'll see you guys tomorrow.